In the vast cosmic theater, where stars twinkle as distant diamonds and galaxies spiral into infinity, human curiosity knows no bounds. The night sky has been attracting humans to investigate the wonders of the cosmos for ages. We are at the beginning of a new chapter in space exploration history, one that will be characterized by groundbreaking discoveries, cutting-edge technology, and an unwavering mission to explore the mysteries buried under the stars. The new space age. Space Exploration 2.0 represents a paradigm shift in our approach to understanding the cosmos. Technology has made it possible for space agencies and private businesses to work together on projects that were once deemed science fiction. Reusable rockets, creative propulsion systems, and commercial spaceflight are starting to become widespread, bringing down prices and boosting the number of space travel. Companies like SpaceX, Blue Origin, and Virgin Galactic are leading the charge, making space travel not just an aspiration for astronauts, but a tangible possibility for civilians. Commercial space companies enter orbit. Nowadays, countries can buy satellites from commercial vendors and avoid the trouble of building their own spacecraft. These satellites can be launched into orbit by commercial space launch companies, saving nations the trouble of developing their own space industrial infrastructure in order to benefit from satellite-based communications, weather monitoring, and Earth observation services. As a result, what was once a government-led activity is now shifting to private industry, and yet international sales remain a relatively small part of the business by modern standards. France, the United States, China, Italy, and South Korea were the top exporters of spacecraft, satellites, and spacecraft launch vehicles in 2021. Blue Origin LLC and Space Exploration Technologies Corporation are the two most prominent privately funded space enterprises in this industry. These companies, which are led by Jeff Bezos and Elon Musk, have made space a more common topic in the private sector. They develop reusable boosters, launch civilians as well as commercial satellites into orbit, and deliver cargo to low Earth orbit. Due to this increase in interest from private companies, overall commercial activity in space nearly quadrupled in growth from $110 billion in 2005 to approximately $423 billion in 2020. Making space for business. In recent decades, humanity has expanded its use of space exploration and utilization beyond its original military function. Billions of people can access the internet thanks to the combination of satellite and terrestrial networks, and farmers and urban planners may use satellite remote sensing data to make well-informed decisions about anything from annual crop plantings to infrastructure improvements. In particular, the use of position, navigation, and timing satellites is growing for uses outside aviation and maritime navigation. PNT-equipped farming machinery allows for greater efficiency when planting seeds and watering crops. As they supply critical timing signals, PNT networks also facilitate monetary transactions, pipeline pumping stations, and cellular communication. The future of space missions. In the coming decades, space missions will focus on private space travel, missions to our own moon, and the study of Jupiter's moons. SpaceX has been launching astronauts into space using its Crew Dragon spacecraft. Some are on private missions, while others are traveling to the International Space Station under contract with NASA. A significant milestone with SpaceX's Polaris Dawn mission is expected in April 2024. The Crew Dragon capsule's 4 commercial astronauts will attempt to reach a maximum orbit of 200 kilometers during this trip. This is higher than any human spacecraft since the Apollo missions. The expedition is being funded by billionaire Jared Isaacman, who also funded SpaceX's first all-private human spaceflight in 2021. In addition, the crew will make the first ever commercial human spaceflight excursion outside the spacecraft. As part of an increased U.S. attempt to return humans to the moon, several unmanned moon landings are planned over the course of the next 12 months. NASA and private space companies plan to travel the 240,000 miles to conduct landing tests, investigate the possibility of usable water ice, and more. Not only the Artemis II mission in 2024 will revisit the moon, but it will also be the first human footsteps on the lunar surface after NASA's last manned moon mission in 1972. Significantly, this effort marks a return to more complete forms of space travel, as opposed to merely orbital flights. The European Space Agency's intriguing new Jupiter Icy Moons Explorer mission also was launched this year, with the mission of exploring the ice moons of the largest planet in our solar system, Jupiter. The spacecraft is expected to enter its orbit in 2031. Once there, it will conduct in-depth studies of Jupiter's moons, Ganymede, Callisto, and Europa, all of which are believed to conceal oceans that could support life. The dangers and challenges are real. It is important to remember that space travel is still an extremely costly and dangerous activity for both the financial sponsors of missions and the individuals who choose to take part in them. The most powerful rocket ever built, SpaceX's Starship, recently underwent a rapid, unscheduled disassembly after launch, while the Hakuto R moon lander, built by a Japanese company called ISpace and carrying a lunar rover developed by the UAE, lost contact with Earth upon touchdown in April. These instances are certainly something to think about for anyone planning for the next major space mission. Furthermore, future space missions will be evaluated based on resource efficiency and sustainability. While SpaceX's reusable rockets have reduced the cost of launching rockets into space by 10 times than it was a decade ago, space missions are still very expensive. The high cost of materials and the time commitment required to design, manufacture, and launch an effective spacecraft that can ignore the harsh conditions of space present another challenge for both current and future space missions. Resources such as water, oxygen, and fuel will be limited in space. This means that future missions will need to be planned with resource limitations in mind, and new technologies will need to be developed to support long-duration space missions. Finally, a glimpse into the future. There will likely be an increasing number of advancements in satellite and aerospace technology as long as commercial space enterprises carry out their aerospace manufacturing, space research, and space travel operations. However, as the sector develops, the twinkling lights in our night sky will gradually seem closer than ever, and someday, perhaps before too long, our planet will be connected to the rest of our solar system. These will provide us with a clear picture of our planet, enabling us to move forward more quickly and create a future that excites all of us.